Okay, I'm now recording. Good. Okay, so in how many ways can 8 books be arranged on a shelf? Let's look at that one first. And actually, before we, I need a new file for this lesson. Let me save this. Give me 1 minute. Okay, so now this is, I'm going to call this lesson 20. Well, this is review for the final. Just modified. Okay, so this is review for the final. So let's look at number 10. And so number 10 said, in how many ways can 8 books be arranged on a shelf? Okay, so I'll put this on the screen in a second. Just going to typing it. So where are we? Okay, here we go. So for number 10 on the review sheet, this is the review sheet. Okay, so if you have a shelf and there you have 8 books and you want to arrange them, you have 8 choices for the first book, times 7 for the second, times 6 for the third, times 5 for the fourth, times 3 for the times 4 for the next one. What? Sorry.
8 factorial?
Yeah, exactly. So then now you just multiply them out, and that's 8 factorial. And so then you get to 8 factorial, you get 56 times 6, 336. That's 336 times 56, 336, and then it's 20, 61, 20. So 336 times 120, and you get so you get 47,040. This is 47,040. Okay. Is that right? 8 times 7 is 56 times 6. Yeah.
Professor, I got 40, 30, 40, 32, 40,320.
In a calculator?
Yeah, in a calculator, yeah.
Okay, let me use the calculator then. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 40,320. Yeah, so I was looking at that number. I was like, that's not 8 factorial. So, okay, so 40,320.
We work with a number of schools all over the country, specifically special education.
There's adds to show up on my calculator. Okay, so that's 40,320. Okay, so okay, great. Okay, so okay, so another problem is number 9. It says if the variance of 3x plus 5 is 18, find the variance of x. This is another quick problem. So I'll put this on the whiteboard on Word. So we have a formula that says that the variance of ax plus b is equal to a squared times the variance of x. And so that means that the variance of 3x plus 5 is equal to 3 squared times the variance of x, right? But the variance of 3x plus 5 is given to you as 18, and 3 squared is 9. So this is equal to 9 times the variance of x. So we have that 9 times the variance of x is equal to 18. And so that means you just divide both sides by 9. You get the variance of x is equal to 2. Okay, and so that's the answer to number 9. Okay, so now other problems. 8, define a sample space for the following experiment. Throw a dice and toss a coin. Let's do that one. Okay, good. Okay, so we want to define a sample space. So the sample space would just be all the ways you could throw a dice and toss a coin. So the option for throwing a dice, right, is 1 through 6. And for each of them, you can either do heads or tails. So you have 1 H, 1 tails. You could have 2H, 2H. You could have 2 tails. 3H, 3 tails. 4H, 4 tails. 5H, 5 tails. 6H, 6 tails. And I hope I got the order right. Right, so you throw a dice and toss a coin. So those are the 12 ways. 1, 2, 3, 4, 5, 6, 7. So that is a sample space for that experiment, where the first component is the result of throwing a die, and the second component is the result when you toss the coin. That's the 8th problem. And I'm kind of just going around in any order. Let's say number 4. Find the probability of getting at least 3 heads in 10 tosses of a fair coin. Number 4. So you had this up on the screen the whole time, I hope, or you didn't. So this is the Word file I was typing on the whole time. So this was number 10, which was on the screen. Number 9 was on the screen. This was the sample space I was talking about. So for number 4, find the probability of getting at least 3 heads in 10 flips of a coin. Okay, so I think it was just not up from a second when I moved it. I just had to find the probability of getting at least 3 heads in 10 tosses of a fair coin. And 10 tosses a fair coin. Okay, so if you toss the coin 10 times, you can think of each toss of a coin is a Bernoulli trial, where the probability of success is 1/2, right? And so that means you have 10 trials with probability, 10 Bernoulli trials with probability of success equal to 1/2. I guess we're saying that again. Okay, so the probability, and we're going to let capital X equal to the number of successes. So X is the number of successes. And so what we want, is the probability that the number of successes X is greater than or equal to 3. Okay, we want the probability that, okay, let's say X is the number of heads in 10 tosses of a fair coin. So better way to put it. Okay, so we want the probability that the number of heads in 10 tosses of a fair coin is at least 3, greater than or equal to 3. And so that's equal to the probability. So that's equal to 1 minus the probability of X less than 3. And that's equal to 1 minus the sum of all the probabilities when x is less than 3. So probability x equals 0 plus the probability x equals 1 plus the probability that x equals 2. And so that's equal to 1 minus. Now the probability that x is equal to 0, that's just the value of the binomial probability density function when the number of successes is 0 in 10 Bernoulli trials, where the probability of success of each trial is 1/2. That's plus the value of the binomial probability function where you have 1 success in 10 Bernoulli trials where the probability of success is 1/2, plus the probability of success in 10. So if you have 2 successes in 10 Bernoulli trials where the probability of success in each Bernoulli trial is 1/2. So you just say 1 minus the sum of the values of the binomial probability density function for those values. So you have so here you have okay, so you have 10C0, 10 choose 0 times 1/2 raised to the number of successes, which is 0, times 1/2, which is probably a failure, raised to the number of failures, which is 10. So that's when you have 0 successes. Plus, now if you have 1 success, then you have a 1 here, and then this is a 9. So you have the number of ways to choose one of the 10 trials to be successes times the probability that there's 1 success. If there was the first trial was a success and the other 9 were failures, that would be the probability of the product of these 2 numbers, and then 10 choose 1 is the number of ways to arrange the 1 success and 9 failures. Okay, so now this is plus, and now if there are 2 successes, it's 10 choose 2 times 1/2 squared times 1/2 to the 8th power. Okay, and so now that's the value of that. This is equal to 1 minus the sum. Well, the first thing is just 1/2 to the 10th power. And so 1/2 to the 10th power, I think it's 1 over 1024. So that's that one, plus the denominator is going to be 1024 again, but now we have 10 in the numerator. And then the last one is going to be 1024 in the denominator. In the numerator, we have 10 choose 2, which is 10 times 9 over 2 times 1. So that's 45. So you have 45 in the numerator there. Okay, so 5 times 9, 45. Okay. So that's the value of 10 choose 2. So now that's your expression there. So this is 1 minus that sum. So in the denominator, you have 1024. And in the numerator, you have 1 plus 10 plus 45, which is 56. Okay, so it's 1 minus 56 over 1024. And so if you plug that into your calculator, you will get 1 minus 56 divided by 1024. And that's equal to 0.9453. So 4 decimal places. And so that's the probability of getting at least 3 heads in 10 tosses of a fair coin. Okay. Okay, so another problem. Okay, so another problem is count the distinct permutations of all the letters in the word telephone. That's number 2. So number 2 is count the distinct permutations of the letters in the word telephone. Okay, so the method here is simple. So the number of letters in the word telephone is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 factorial. And so is 9 factorial. So you have 9 factorial ways to arrange 9 things. but then you have to divide every time there's repeated letters. So for instance, E is repeated 3 times. So there's 3 factorial ways of arranging those 3 E's. 3 things, but the 3 E's are the same. So if you rearrange 3 letters that are the same, you're not changing the word. So wherever you have 3 letters in an arrangement of the 9 letters, if you rearrange just the 3 E's, you have the same word. So you have to divide by 3 factorial there in order to get rid of the overcount. And then we check if any of the letters repeated. T is not repeated, L is not repeated, P is not repeated, H is not repeated, O is not repeated, N is not repeated. That's the only one that's repeated. So the answer is 9 factorial divided by 3 factorial. So it's 9 times 8 times 7 times 6 times 5 times 4. Okay, and so that's equal to 60,480. That's the number of distinct permutations of the letters in the word telephone. That's number 2. Okay, so 1 is toss a coin 3 times. Let X be the number of heads minus the number of tails. Find E of X. Okay. Okay, so we want to find E of X. So when you toss a coin 3 times, let me go to the whiteboard for this. So if you go, okay, so this is number 1. Toss a coin 3 times, let X be number of heads minus number of tails. Find E of X. Okay, so you toss a coin 3 times. Never mind, I'll just do it this way. Okay, so okay, so let's say we let A be the number of heads. Or, you know what, let me just put number of heads. And here, number of tails. And here I'm going to put X, which is the number of heads minus the number of tails. And so if you toss a coin 3 times, there are 9, there's eight ways that could happen. 2 times 2 times 2, which is 8. So there's 8 possibilities. So for each of those possibilities, you have a corresponding number of heads, number of tails, and value of X. So we want in this table are just the values of those things for all 8 possibilities. And so now I'm wondering, there's enough room. Sorry. Okay. This way. Sorry for the table. Okay, so now these are all the possibilities. So if you toss a coin 3 times, you're going to have heads, heads, heads. The order triple, the order of the things are saying the order of the results of the flip. So it's head first, head second, tails third. That's that one. You have heads, tails, heads. You have heads, tails, tails. H there. You have tails, heads, heads, tails, heads, tails, 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 heads, and then tails, tails, tails. Okay, so those are the 8 possibilities. So the number of heads here is 3. The number of tails is 0. So x is the number of heads minus number of tails. So it's 3 minus 0, which is 3. Number of heads here is 2, and the number of tails here is 1. So 2 minus 1 is the value of x, which is 1. This, the number of heads, is 2. And here the number of tails is 1. So 2 minus 1 is 1. Number of heads here is 1. Number of tails here is 2. 1 minus 2 is negative 1. Equals negative 1. Here the number of heads is 2. The number of tails is 1. So x is 2 minus 1, which is 1. Heads 1, tails 2. 1 minus 2 is negative 1. Here the number of heads is 1. The number of tails is 2. The value of x is 1 minus 2, which is negative 1. And then here the number of heads is 0. The number of tails is 3. 0 minus 3 is negative 3. Okay, so for all 8 simple outcomes of this experiment, tossing a coin 3 times and recording the number of heads each time, for all 8 of those simple outcomes, there's corresponding values of x. The probability of each of those simple outcomes are the same. And so you have 1/8 chance of each of these simple outcomes. And so each of those 8 possibilities with 1/8 probability have corresponding values of x. So for instance, the probability that x equals 3 is just 1/8. The probability that x is equal to 1, well, you have 1 here, 1 here, and 1 here. There's 3 of them. It's just a 3/8 chance that x equals 1. And then for negative 1, we have a negative 1 here, a negative 1 here, and a negative 1 here. There's 3 of them. So there's a 3/8 chance that x is negative 1. And then x equals negative 3 just one time. And so there's a 1/8 chance that x equals negative 3. Okay, and so the goal is to find the expected value of x, find e of x. And so to find e of x, we're just going to take the sum of products where each product is a value of x times its probability. So ex is equal to, so the possible values of x, again, x could either be -3, -1, 1, or 3. So x could be -1 times its probability. X could be what? X could be -3 times its probability, plus could be -1 with its own probability, plus x could be 1 with its own probability, and x could be 3 with its own probability. So each of those possible values of x have their corresponding probabilities. The probability x equals -3 is 1/8, and the probability x equals 3 is 1/8. So each of these have probability 1/8. Okay, and then -1 appears 3 times, and 1 appears 3 times. So each of them have 3/8 chance of happening. And so now the sum of those products is the expected value of x. But now this is equal to -3/8, -3/8, plus 3/8, plus 3/8. And that's equal to 0. So the expected value of x is 0. And we're done. Okay, so that's the answer to number 1. So this is number 1. Continued. And so we succeeded finding e of x.
Professor?
Question?
Yes, Professor. Is there a reason that the value was x, or it could have been something else?
You could give, it's just a variable, right? Just like if you were doing an algebraic equation, like 2x plus 1 equals 3, you could write 2y plus 1 equals 3, right? Unless another variable has another meaning, you can call this one anything you want, right? It could have been called x, it could have been called y, but it doesn't matter.
Thank you, sir.
You're welcome. So like if you change the name of a variable, you don't change what it is simply by changing its name.
No, but I meant the e of x, the final value, as it was 0. I was wondering if it could have been something else, or just like, it's true.
No. So how we define x, right, as being the number of heads minus number of tails for this experiment, the way it's defined, there's only one value of e of x. It's 0.
And if the value would have been something else, then we would have done something wrong, right?
Yeah, yeah. I mean, the answer to this problem is 0, right? So if you have a different answer, then that means it's wrong. Yeah.
Thank you.
Okay. Good. Okay. So, okay. Wait, not over there. Here. Okay. So we did 1. We did 2. Okay. So let's do number 3. 5 cards are dealt to a player from a standard 52 card deck. Find the probability of the flush. Number 3. Okay, 5 cards are dealt to a player from a standard 52 card. Find the probability of a flush. And so remember, a flush is a poker hand where all 5 cards are of the same suit. Okay? Okay, so solution. Okay, so the probability of a flush. So we equal to, so normally, right, when we have an event, right, we want to talk about, so let's say I call the capital F equal to the event of the flush. Okay, so capital F is the event of the flush, but do it without deleting everything else. What's going on? Okay, let's try this again. So let's say capital F is the event of a flush. Okay, so P of the probability of a flush is equal to the probability of the event capital F. And so we know that this is N sub F over N, right? What this is a lowercase n. Okay, so N sub F is the number of flushes, and capital N in the denominator is the number of poker hands, right? So if you know the number of ways to get a flush and you divide it by the total number of possible poker hands, that's the probability of getting a poker hand that is a flush. Okay, so the numerator is equal to the number of flush hands, right? And the denominator is the number of possible poker hands. I'm just saying it several ways just to help you understand this. So now the number of possible poker hands, a poker hand consists of 5 cards. So note, a poker hand consists of 5 cards given to a player from standard 52 card deck. Okay, and so if you have 52 cards and you want to know how many ways can you get 5 of them, it's just 52 choose 5, right? 52 choose 5 is the number of ways to choose 5 things in a set with 52 distinct elements in it. So 52 choose 5 is the number of ways to choose 5 cards from a standard deck of 52 cards. That's the number of possible poker hands. Numerator is the number of flush hands. Okay, but if you're going to get a flush, if you're going to get 5 cards of the same suit, let's just say what a standard 52 card deck consists of the following cards. So you have 13 types of cards, right? So 13 types of cards. So that would be ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. Right. So now you have 13 types. Each of those 13 types have a card of each of 4 suits. Okay, and so those 4 suits are spades, which is black, hearts, which is red, clubs, which is black, and diamonds, which is red. Okay, so you have 13 types of cards: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, 13 types. And for each of those 13, you have 4 of them, where the 4 is 1 spade, black spade, 1 red heart, 1 black club, and 1 red diamond. So if each of these 13 types have 4 cards each, 13 times 4 is 52. So that makes up the entire 52 card deck. And just note for other problems that jacks, queens, and kings are called face cards. Okay, an ace is not called a face card, right? An ace is not a face card. Okay, and so there are 12 face cards, right? 4 jacks, 4 queens, 4 kings, so there's a total of 12 face cards. That's a side note. Okay, but then this is what the standard 52 card deck consists of. And that's just a side note of that. Okay, so what we want is the number of flush hands. So to have the number of flush hands, we want to choose 5 cards from the deck that are the same suit. So to get a flush, the following has to happen. Okay, 1, you need one of the 4 suits in which all 5 cards are of that suit. Okay, that makes sense. So if you have a flush, it can only be 5 cards that are hearts, 5 cards that are spades, 5 cards that are clubs, or 5 cards that are diamonds. Okay, so in step 1, you choose a suit. Okay, and so the number of ways to choose a suit is just 4 choose 1. Okay, 4 choose 1. The set is 4 suits, and you want to choose one of them. Well, 4 choose 1 is the number of ways to choose a suit out of 4. That's just 4, right? So after you choose a suit, now imagine this. Okay, you choose a suit. Let's say you choose hearts. You had 4 choices. Let's say you choose hearts, one of the 4. Now get rid of all the cards in the deck that are not hearts. Okay, so that means you're left with the 13 cards that are hearts. And let's say you put them on the table. So now you only have 13 cards in the hearts. These are the only cards now you can choose for your flush hand because it's going to be a flush of hearts. Well, you need a flush. You need a flush, poker hand flush, which is 5 cards. So that means you need, of those 13 cards of that suit, you need to choose 5 of them to be in your hand, your flush hand. So after you choose a suit, then imagine you take the 13 cards of the deck of that suit you chose. Then the number of ways to then get to get a poker hand, you need to choose 5 of those 13 cards for your flush. Okay, so first 4 choose 1 is the number of ways to choose a suit. And then after that, 13 choose 5 is the number of ways to choose 5 of the 13 cards of that suit you chose to be in your hand. So when you multiply the 2, that's the probability that you get a particular suit and you get 5 cards of that suit. So 4 choose 1 times 13 choose 5 is the number of poker hands that are flushes. And so the number of flushes divided by the total of poker hands, that's the probability of getting a flush. And so when you compute that, you get the final answer, and that's the probability of the flush. So that's number 3. Okay? Okay. Okay, let's look at number 5. Consider a throw of 2 dice. Let x be the sum of the values of the 2 dice. Find the cumulative distribution function of x. So for number 5, let's say throw 2 dice. Okay, then let x be the sum of the values of those 2 dice. I'm just paraphrasing the same problem. Throw 2 dice, let x be the sum of the values of those 2 dice. Find the cumulative distribution function of capital X. Okay, let me make sure I got that right. Yeah, okay, same question, just paraphrasing. Okay, so the solution. Okay, so what are the possible values of x? X is the sum of values of the 2 dice. So what are the possible values of x? Well, x could be, the smallest sum would be if you did 1 plus 1, which is 2, right? The first dice is 1, the second dice is 1, the sum is 2. The largest it could be is 6 plus 6, which is 12. And you can get all the numbers in between. So the possible values of the sums, or x, is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all the numbers 2 through 12 are all the inclusive, are all the possible values of the sum of two dice rolls, or x. Okay, and so each of those possible values of x has a probability. Okay, and so the probability we've computed in class before. So f of x is the PDF of this capital X. It's the probability that capital X takes on different values. Okay, so I'm going to move this to the next page so I don't run out of space. So the probability that x is equal to 2 is equal to 1 over 36 if x equals 2. The reason is the only way to get a sum of 2 is if you roll a 1 and then a 1. And so it's a 1/6 chance of rolling a 1 and a 1/6 chance of rolling a 1 again. That's 1 over 6 times 1 over 6, 1 over 36. That's if x equals 2. So all the ways to get one roll and then another roll is 1 over 36, right? So now, let's say you have a sum of 3. The sum of 3 could happen 1 plus 2 or 2 plus 1. So that's 2 over 36. So there's a 2 over 36 chance if x is 3. Because there's two ways to roll the dice. 1 plus 2 or 2 plus 1. Now to get a sum of x equals 4, there's a 3 over 36 chance if x is 4, because you could have 1 plus 3, you could have 2 plus 2, or you could have 3 plus 1. There's 3 ways. Now the probability if x equals 4 is 4 over 36, so you can see the pattern. This is if x is 5. So if the sum to be 5, you have 1 plus 4, 2 plus 3, 3 plus 2, 4 plus 1. There's 4 ways of that happening. And then the probability is 5 over 36 if x equals 6. So you can have 1 plus 5, 2 plus 4, 3 plus 3, 4 plus 2, 5 plus 1. So there are 5 ways that could happen. And now there's a 6 over 36 chance if x is 7. Because you have 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 3, 5 plus 2, 6 plus 1. There's 6 ways that can happen. Now, if x equals 8, then you cannot do 1 plus 6. You'd have to do 2 plus 6. So it'd be 2 plus 6, 3 plus 5, 4 plus 4, 5 plus 3, 6 plus 2. There'd be only 5 ways to get x equals 8. So it starts decreasing in probability now instead of still increasing. And it's a 4 over 36 chance if x is 9, because there's only 4 ways to get a sum of 9. That would be 3 plus 6, 4 plus 5, 5 plus 4, 6 plus 3. So there's only 4 ways to do that. And then you could have, there's a, no, okay. Good, okay. Then there's a 3 over 36 chance if x is 10, because the only possibilities for the sum to be 10 and 2 rolls would be 4 plus 6, 5 plus 5, or 6 plus 4. And then there's a 2 over 36 chance if x is 11, because the two possibilities are 5 plus 6 or 6 plus 5. And there's a 1 over 36 chance if x is 12. That would be 6 plus 6. Okay. So this is the PDF for the sum of 2 rows of a die. Okay. The sum of rows of 2 die, or value of x. And so to find a cumulative distribution function, you just use that PDF function there. So f of x is equal to, so if x is, so saying that the largest value of x is 2 would be 1 over 36. Or let me put it this way, it would be 0 if x is less or equal to 1. So the probability that capital X is at most 1, or anything less than 1, would be 0, because the smallest value of x is 2. Now the probability is 1 over 36 that if x is equal to 2, I'm only consider integer values here, so I don't care about the values in between. So the probability that x is at most 2, not equal, at most 2 is 1 over 36. There's no other possible value before 2. That's why it's the same. But now if x is equal to 3, you're adding those. So you get 3 over 36 if x is 3, because it's the probability of x equals 2 plus the probability of x equals 3. And then the next one, if x is 4, you have another 3 over 36. So this is 6 over 36 if x is 4. That's probably that capital X is at most 4. Then you get another 4 over 36. You get 10 over 36 if x is 5. You now add a 5 over 36. So you get 15 divided by 36 if x is 6. So now if x is 7, x at most 6, right? Now adding the next value, you have another 6 over 36. That's 21 divided by 36 if little x is 7. And so now for x equals 8, you have another 5 over 36. That's 26 divided by 36 if x equals 8. For x equals 9, you have another 4 over 36. This is 30 over 36 if x is 9. And then if x is 10, you have another 3 over 36. This is 33 divided by 36. And this is if x is 10. And then if x is 11, you have another 2 over 36. So it's 35 over 36 if x is 11. And then if x is 12, you have another 1 over 36. So now you have 36 over 36, which is 1, if x is equal to 12, but also anything larger than it. So x greater than 12. So integer values. So that's capital F of x. That's a cumulative distribution function of capital X. That's the answer to the problem. And you can simplify it to some of these fractions. Okay? I wrote it this way. That way you can visualize how I'm getting these values from the other ones by adding them. If I keep the denominators the same the whole time, it makes the easier to see equations. Okay, so that is number 5. Okay, so I think I'm gonna have to stop there because I have to go. But so I think I did a lot here. So I think this definitely helps in your study for the final, right? So again, the final is on, so for going back for this is math 241. The final is on December 21st from 6:15 p.m. to 8:15 p.m. Okay, so let me remind you at the top. Okay, good. So reminder, the final for math 241 is on December 21st. 2021, and the time is 6:15 p.m. to 8:15 p.m. Okay, so the final for math 241 is on December 21st of this year, from 6:15 p.m. 8:15 p.m. and I will send the Zoom link for the final the day before. Okay, so I will send it on December 20th. Okay. And so then you use that Zoom link to join the meeting at 6:15 p.m. Okay, when the exam starts. And so then you'll take the exam now. Okay. I'll grade the exam you took today, and you'll get it back in a few days. Okay, within a few days. So you'll know you grade on that one way before the final on the 21st. Okay. So have a good night. And I hope this helps. Okay.
Thank you, Professor. Thank you.
You're welcome.
Thank you, Professor. It's such a great help, really.
Oh,
for spending
means a lot.
time at
Means
night.
a lot to you. Appreciate it.
Thank you. Have a good one.
You too. You're welcome.
Professor?
Yeah.
Would you mind saying like the Zoom link, maybe another one, like before, maybe 1 hour before the exam start? Because some people have like exam in a day before, so everything gonna be like a mess. something like that. Do you mind doing
I-
that?
I really have a lot on my plate. I want to just do it now. So I hope this helps. But yeah, I need to do other things too. So
Oh, okay, okay, got it.
but I hope this helped. And so I saved the whiteboard. So I will upload once I have free time. I'll be able to upload it. And so this stuff will be on Blackboard and on YouTube the way it normally is. Okay, so you can refer to this stuff, and there's the review sheet still, and you can go over the textbook and homework stuff and for that to review. Okay. All right. So good night. Thank you for taking my class again, and see you on the day of the file.
Thank you.
You're welcome.
Thank you.